Hey calculus, we are going to learn how to find the equation of a tangent line. The fancy name for tangent line in calculus is a linear approximation. Okay, so remember the derivative is the same as the slope. In order to have a slope, you need a line. So we find the equation of the tangent line. And that will allow us to approximate a function. And we'll get into that a little bit later. But there are three things that you need to find the equation of a line. All right, you need an x, you need a y, and you need an m, a slope. In all of our examples, you will be given an x value. So let's look at example number 1. We want to find the equation of the tangent line at x is equal to 5. So again, we will always be given the x value. And then for this function. So we're going to find the equation of the tangent line that brushes up against this parabola at 5. All right, so the first thing we want to find is the y value. All right, so here's the first step. To find the y value, we simply find f of 5. We plug 5 into the original equation. All right, and when we plug 5 into the original equation, we get the value, y value of 3. All right, so that gives us the point 5, 3. 5 is our x value that was given to us. Y is 3. That's what happened when we plug 5 into the function. The easiest way to do that is just use your calculator. All right, go around right here and plug in the original function. Right here, x squared minus 8x plus 8. When I start my table at 5, there's my y value right here. All right. The second thing that we need to find an equation of a line is the slope. Remember, the slope is the derivative. So we find f prime of 5. So if we go underneath here and we find the derivative function, we know that the derivative of x squared using the power rule is 2x. We know the derivative of negative 8x using the power rule is negative 8. So if I find f prime of 5, I just plug 5 into that line. 2 times 5 minus 8. All right, which gives me 10 minus 8, which gives me 2. So my slope is 2. I can also use my calculator to find that. Look over here. Down in y2, I punched in my derivative, 2x minus 8. And right here, there's my slope 2. So by all means, use your calculator table to find your y value and your slope. Okay, now we're ready to write our equation, step 3. In calculus, we use point-slope form, and it looks like this. It is y minus the y-coordinate. You plug your y-coordinate in right here. And then it is equal to the slope. You plug your slope in right here. And then it's times x minus the x-coordinate. You plug in your x value right here. So you just plug those three things in. We're going to try it right here. So y minus the y-coordinate is 3. Y minus 3. It is equal to m. I know my slope is 2, so that goes right here. And then it's x minus the x-coordinate. My x-coordinate was given to me 5. All right? So there is my point slope. Y minus 3 is equal to 2 times x minus 5. Now, if we simplify this, we can get it into slope-intercept form. So y minus 3 comes down. I can distribute the 2, and I get 2x minus 10. Now I just solve for y. I just add 3 to both sides. And that gives me y is equal to 2x minus 7. And that is my slope-intercept form. All right, so there is the equation of the tangent line. All right, in point-slope form, it looks like this. Y minus 3 is equal to 2 times x minus 5. In fact, I might kind of just write that out simpler for you. Y minus 3 is equal to 2 times x minus 5. And you can just leave it like that. That right there, you guys, is point-slope form. That is the point-slope form equation of a line. And you can also write your equation in slope-intercept form. And that's what we did right here. Y is equal to 2x minus 7. Now, how do you check your work? Well, we go down to this part of my note sheet right here. All right. You can graph in y1 what you, graph the original function, x squared minus 8x plus 8. In y2, graph what you think the tangent line is, and hit graph. And you can see right here, all right, this tangent line brushes up against that parabola at x is equal to 1, 2, 3, 4, 5. So right up here. All right? Now, if you zoom in on that point a few times, that line and that curve will become the same. So we can use that tangent line to approximate the function. Okay, let's try these. By all means, use your calculator table. So the first step is you find the y value. All right, so you find f of 3. All right, my given x value is 3, so I plug that into the function. All right, well, I know right off the bat, hey, 3 squared is equal to 9. So that is my y value. So my point, the x value is 3, and the y value is 9. All right, so we have our y value, we have our x value. The second step is we need to find m. All right, and we use the derivative function because the derivative is the same as the slope. So we find f prime of 3. All right, well, we know that f prime is equal to 2x. All right, I'm going to go up here. The derivative is equal to 2x. So we just plug in 3 into that. And 2 times 3 is equal to 6. And that is my slope. All right, 6 is my slope. All right, now we write the equation in point-slope form. All right, and we always use point-slope form in the calculus world. So it is y minus the y value. So we plug our y value in right there. So my y value is 9. Then it is equal to our slope. We just found our slope was 6. And then it's another set of parentheses, x minus my x coordinate, which is 3. All right, so there you have it. That is my equation in point-slope form. All right, so let's label that so we're clear on that. That is point-slope form. All right, now, in order to check our work, we need to graph it, so we need slope-intercept form. So let's simplify this and put it in slope-intercept form. The y minus 9 comes down. We distribute the 6, and we get 6x. Right here, 6x, and then minus 18. And then we simply add 9 to both sides. All right, so I'm going to go off to the side here. In slope-intercept form, my tangent line equation is 6x minus 9. And that is slope-intercept form. Alrighty, and you can use either one of those, whichever one you like. Slope-intercept form. All right, now to check your work in y1, I'm going to go up here. In y1, you put the original equation that you're given. And in y2, you put in your tangent line equation. And then you hit graph, and you see if that line is tangent to the curve at the given x value. All right, so that is to check. And you always want to do that. Okay, number 2. We want to find the equation of the tangent line of our curve, x cubed minus 2x. And I need to scooch it over here, and the x value is 2. All right, so the first step, we want to find y. So we need f of 2. We plug 2 into the original function. So 2 cubed is 8. 2 times 2 is 4. 8 minus 4 is 4. So there is my y value. 2, 4 is my point. X is my 2 that was given. Y is 4. The second step, I find m. So I plug it into the derivative, f prime of 2. I plug my given x value 2 into the derivative. Ready? By all means, use your calculator table. My derivative is 3x squared minus 2. If I plug 2 into that, my slope is 10. All right, so that is my m. Third step, we write the equation in point slope form. Y minus the y coordinate, which is 4, and then it is equal to my slope, 10, parentheses, x minus, and then I plug in my x minus 2. Okay, that is my equation in point slope form. And that's as far as you need to go. To check your work, you just simplify it. All right, get it into slope-intercept form. All right, so you leave the y minus 4 alone. You distribute the 10 and get 10x minus 20. And then you simply add 4 to both sides. All right, so if I go over here, that's going to give me y is equal to 10x minus 16. So that is my equation in slope-intercept form, and that allows me to check our work. All right, again, I'm going to write them in. This is point slope form, and this is slope-intercept form. All right, again, slope-intercept form allows you to check your work. All right, and finally, number 3, we want to find the linear approximation. Again, don't let that fancy word trip you up. That's a fancy calculus way of saying find the equation of the tangent line. Exactly what we've been doing. First step, we find we find y. Find y. So we plug our given x value into the original function. So we need f of 1. When I plug 1 into my equation, we get 1. All right, so my x value is 1 and my y value is 1. That should make things easier. Second step, I find m. So I plug my given x value into my derivative, f prime of 1. Please use your calculator. All right, we know the derivative of this. I'll just go off to the side. The derivative using the power rule of x to the 1/2 is 1/2 x to the negative 1/2. And I would enter that as 0.5 x to the negative 0.5. Use your calculator table. When I plug 1 into the derivative, I get a slope of 0.5. So that is my m. Now I'm ready to write my equation. Third step, point slope form. Y minus the y coordinate goes right here. All right, then you have equals. Then you put your slope right here in front of a set of parentheses, 0.5, and then x minus, then you plug your x coordinate in right there. That is your equation in point slope form. Point slope form. I really want you to know the difference. In calculus, we use point slope form. All right, and then to check your work, remember, you just simplify and put it into slope-intercept form. All right, so we bring down the y minus 1. We distribute the we distribute the 0.5. So we get 0.5x minus 0.5 times 1 would be minus 0.5. And then we simply add 1 to both sides. All right, so my slope-intercept form would be 0.5x plus 0.5. And that is my equation for the equation of the tangent line in slope-intercept form. All right, this is my slope-intercept form. All right, and again, check your work. You put the original function in y1, you put what you think the tangent line is, and you graph it. All right, thanks, calculus.